Question 1. In order for a magnesium atom to achieve stability, what must it do? And what is the final charge on the magnesium ion that forms? So in order to do this question, we need the dot structure, okay, or the dot diagram. So let's start with that. So here's our dot diagram. Or in this case, it's not really a dot diagram as much as it is an electron configuration diagram. So this is not a Lewis dot diagram, this is just an electron configuration. So a magnesium atom has 12 electrons in total. So if we count them out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. And as you can see, the first and second shell are both full. The first shell has 2 electrons, the second shell has 8 electrons. Now the outermost shell, which is the third shell, this one, has only 2 electrons. Okay, so we need to get to 8 or get rid of those 2. So in order to achieve stability, it could either obtain 6 electrons, or what it could do is remove those 2 and drop this shell completely and only have 2 shells. Now it's easier to remove 2 than it is to gain 6, so it might as well just remove those 2. So after the removal, there are only 10 electrons. So let's just put a cross through these guys. So they're not there anymore. So now there's only 10 electrons and 12 protons. And this means that there are 12 positive charges and 10 negative charges. Okay, so if you add them together, the magnesium ion will have a net charge of 2+. So in order for fluorine atom to achieve stability, what must it do? And what is the final charge? So again, we draw the electron configuration. So if you look on your periodic table, its atomic number is 9. So it has 9 protons, and it will have equally 9 electrons. The atom, that is. So if you do the diagram, it says in the first shell, there's 2 electrons. There you go, 1, 2. The outermost shell has 7 electrons to make 9 in total. 1, 2, 3, 4, 5, 6, 7. Great. So in order to achieve stability, it could either remove 7 electrons from this shell, or it could gain 1. Now obviously it makes sense to gain 1, then give away 7, so it's going to gain 1. Now once it's gained an extra electron, there are now 10 in total. 10 electrons and 9 protons. Okay, so 10 electrons, 9 protons. Therefore there is 1 more electron than proton, so the net charge of the fluoride ion is -1. Okay? Because it's got an extra electron, it has 1 more negative charge than positive charge, so it's a -1 ion. Now for a carbon atom, is it more likely to form a positive or negative ion? This is, time for your periodic table to look it up. So what group is it in? Well, it's in group 4. So since the carbon atom has 4 electrons in its valence shell, it can either give away or gain 4 electrons. Now, because going up 4 or down 4 is the same number in terms of magnitude, both options are equally likely. Okay, so they both have equal chance. The ion that the carbon atom will form will depend on the other atom in the reaction. So if there's another atom in the reaction, what ion the carbon atom will form will be related to what that other atom is. So if the other atom is an atom that wants to give away electrons, like sodium, the carbon atom will form a negative ion. If I put carbon with something that really wants to get rid of electrons, then the carbon will happily accept those electrons and become negatively charged. Whereas if the other case is, if the atom wants to take in electrons, it will give away those electrons and become a positive ion. So you can see for group 4, it's a little bit hard to judge. And that's why group 4 generally doesn't really form many ionic compounds. There are very few ionic compounds made from group 4. Okay. So draw the Lewis dot diagram for the reaction between magnesium and oxygen. So magnesium is in group 2 and oxygen is in group 6. So we start with this. Magnesium has 2 electrons in its outer shell, and I represent them with dots. And oxygen has 6, and I represent them with X's. 2, 3, 4, 5, 6. Obviously these 2 join this one. And you can see there's now 8 in this atom, or ion now, and the magnesium has lost its outer shell. And so it becomes this. It's a 2+ ion and 2 negative ion, so you can see how that works as well. Okay, so that's how we draw a reaction in Lewis diagrams. So when ions are formed, what holds the 2 ions together to form a substance? So what actually holds the ions together? Well, when ions are formed, they're oppositely charged. Okay, we know this because the electron goes from one to the other. Similar to the opposite ends of a magnet, opposite charges attract one another. And this force of attraction holds the new substance together. Okay, so that force of attraction actually holds the new substance together. And this force that holds them together is called electrostatic attraction. So that concludes today's lesson on ionic bonding. We looked at what an ionic bond is, why they occur, and how to represent them with certain diagrams. Okay? So hopefully you've learned something about ionic substances, and in the future lessons we'll talk about covalent bonding and the other way atoms can achieve stability with other atoms. So I look forward to seeing you at our next lesson.